Let's um, let's identify some return factors with principal component analysis. Principal component analysis is something that I've seen with uh, in investing for quite a while, and I think I've even made other videos doing this same sort of technique here. And there are some pros and cons to it. The pros are obviously you get to identify like um, the greatest factors toward contributing toward returns. And I'll talk about the downsides when when we get to the end of the video. First, though, we're gonna get everything that we need, which is the usual suspects plus PCA from sklearn. We're doing it for the past 5 years. We're getting the we're getting the close for it all. And we're calculating the returns as just the percent change over time. And we're dropping the null values. So this is what we have for all of that. Excellent, excellent. Now let's also initialize our PCA. We'll be looking at three components. So you can pass through two, you can pass through three. Three is the most common one I've seen, but I think in most scenarios, two captures most of the variance um, that occurs in the data frame. So then we fit the PCA to our returns table and we parse out the explained variance ratio in a variable called PCT and the parsing out the components in something in a variable called PCA components. Now it comes time to plot our cumulative percent using our I can't speak right now. Our cumulative sum of the explained variance ratio, and we arrange that in an array, make a subplot, create some bar charts, and this is what we get. So this graph on this side is showing each of the components and which component contributes to the overall variance in the returns. And this is our cumulative one. So you can see that when we stack all three of these on top of each other, you can see that there's this nice grid right here. So between the three components here, you can see it explains for the variances. Number one having the most, but cumulatively we get up to like over 80% these three factors contribute to the variances in the component for returns. Now, what this is doing is it's transposing the components back into a data frame. And so we have factor one, factor two, factor three. So this is not our returns, but this is like our components. It's taking our returns as an array, taking the dot PCA components transpose and putting that into factor returns. So these are the returns um, that are explained day by day with the components. This is really difficult. This is one of the things I don't like about PCA is that each time I make a video about it, I seem to really struggle explaining what the code is doing under the hood. But this is setting us up for actually plotting the exposure of it, which is what we do here. So we transpose it as exposure, and now we have our tickers and our factors and the variance of the factors, right? So we have our return columns as our columns. We're taking the data of our PCA components with the index of F1, F2, F3, and we transpose that into a factor exposure, take the head, that's what it looks like. And then when we go to plot it, I didn't run this, oops, there we go. And then when we plot it, we can now plot it in a space where factor exposure 2 is our y, factor exposure 1 is our x. And if we look at our portfolio that I had originally, we had a bunch of healthcare stocks, and then these are gold stocks. So you can see that our healthcare stocks are not really affected by either of these factors, whereas our gold is. So you can see that this particular stock here is really really has an exposure to the first factor component, but it has a negative exposure to this second component here. So you kind of get to see what each stock and how it fits within the overall exposure to the factor. Now, one of the downsides I don't really like about PCA is this exercise is great to give you an idea of what is exposed to what factors, but we don't really know what these factors are like in the market. Like like these factor variables could be so many different things. We can kind of get a sense like, okay, these are gold here, these are healthcare here, um, but why healthcare? And it makes sense intuitively, like healthcare isn't going to be affected by the same things gold is affected by for the most part. But the PCA is really just parsing out, um, like it's not telling us like, oh, the PCA one or PCE one is the exposure to market volatility, or it's the exposure to um, any number of things. Like there's almost, I'm even struggling to come up with examples because it could be so many different things. I don't know what it could really be. It could just be the volatility of the time. Like these healthcare stocks did really well during 2020, and I'm assuming gold also did really well as the dollar and inflation went up, but you don't really know for sure if that's the actual factor that is being described here in this graph. So that aspect can be pretty difficult to derive from this exercise, but you can at least get a sense of what groups of stocks are being affected by what things that are calculated. We're going to do this with other types of data, um, and see if we can see if we can gain some greater insight. I think with stock data, this exercise isn't so great, but we can try it with other types of data as well. If you found the video informative, I think this is the best way I've explained it thus far. The code is actually clean in this instance compared to other attempts that I've made in the past. Um, this is pretty straightforward, and you can just plug and play any type of portfolio you want in here to play around with it. So you can go to the description, download this notebook, make a copy of it, and if you find it useful, consider going to this link here and supporting me. It's just a one-time donation if you feel inclined to. No pressure. It's just a way to help me not give into the temptations of sponsors, not give into the temptations of selling a course, both things that I find kind of irritating about YouTube. So I'm trying to stay away from it. But yeah, I will see you guys in the next video. And until then, have a good one. Safe investing out there. Bye.